This is the first of 10 numeracy sessions, decimals. Very basic but very quick reminder on decimals and how we multiply and divide with them. Remember firstly that the decimal point is represented by a dot and not a comma. This therefore is correct and this is not. Warm up on units, tens, thousands. If the number we have is 40.78239, select from the list of options what value does the 7 have. The 7 is just after the decimal point, which means it becomes a tenth. So the answer being C. What value does the 3 have? That's a tenth. That becomes a hundredth, a thousandth, 10,000th. There isn't a 10,000th, therefore option is E. The 0, well, that's just before the decimal point, so that therefore is the position of a unit. So it's a unit, option A. And the 8, that's a tenth, that's a hundredth, again not in the list, so therefore it's none of these. And the 4, if that's a unit, those are the tens. So we've got 4 tens. The answer is B there. If we just look at this table again to demonstrate the place values, you've got on the left of the decimal point you have the units, tens, hundreds, thousands, 10,000s, etc. And on the right of the decimal place you have the tenths, hundredths, etc. So when we're multiplying by 10, what happens is that if you're multiplying, say, a number by 10, you have to move all the digits one place to the left. This therefore means you're making the number bigger. You're multiplying, therefore it stands to reason that the number is getting bigger. So an example here is 2.63 multiplied by 10 gives you 26.3. To multiply by 100, when you multiply a decimal number by 100, you move all the digits 2 places to the left. The number becomes 100 times bigger. So again, if you've got 2.63, you're moving 2 lots to the left, you become 263. Multiplying by 1,000, same again, except this time you move all the digits 3 places to the left. In this case, you'll see that you have to add a 0 because you've got a gap. So 2.63 multiplied by 1,000 becomes 2,630. The number becomes 1,000 times bigger. The opposite is true when you're dividing. So if you're dividing by 10, you move all the digits one place to the right. The number therefore becomes 10 times smaller. Dividing, therefore smaller. So the example in this case we have is 3,502 divided by 10. You can see that the digits move along to the right, therefore it becomes 350.2. Dividing by 100, it's the same again, you're moving the digits 2 places this time because it's 100. So therefore 3,502 becomes 35.02. In the same way, if you're dividing by 1,000, you're moving 3 places to the right, the digits that is, and the number therefore becomes 1,000 times smaller, and 3,502 becomes 3.502. There is a shortcut. If you're doing division and multiplication by tens, hundreds, thousands, we can work with the decimal point. So when multiplying by 10, 100 and 1,000, there's a pattern that can help you get the right answer very quickly. And rather than moving the digits, we move the decimal point. I'm certain this is a more common and quicker, easier method of doing the multiplication. So if you're multiplying the number by 100, you would do it by 2 points. You would move the decimal point by 2 places. By 10,000, because there are 1, 2, 3, 4 zeros, you would move the decimal point by 4 places. So the number of zeros in the number that you're multiplying by or dividing by indicates the number of places that you need to move the decimal point. So for example, if we had to multiply 2.341 by 100, 100 has 2 zeros, 1 and 2. You therefore make 2.341 bigger by moving the decimal point 2 places, 1, 2. It's therefore the same when you divide, except you have to remember to move the decimal point the other way. You're making the number smaller, so the decimal point moves to the left when you're dividing. When you're multiplying, the decimal point moves to the right because you're making the number bigger. So if you had to divide 761.2 by 10, 10 has 1 0. You therefore make 761.2 smaller by moving the decimal point one place to the left, and it becomes 76.12. When multiplying or dividing by 10, 100 or 1000, count the zeros to find out how much bigger or smaller your number must be. Make sure you move the digits or the decimal point, whichever you decide to use, in the correct direction. So if you're multiplying, the decimal point will move to the right. If you're dividing, the decimal point moves to the left. How many places it moves to the right or left depends on how many zeros there are in your number that you're multiplying or dividing by. So let's just do a few questions to practice this. Again, I understand it's very, very straightforward, but it's important we get this correct, and you will see in a little while why it's so important that the multiplication or division of tens, hundreds and thousands is so important. So, true or false? 43 multiplied by 100 is 430. The answer is false. When you multiply a whole number by 100, you put 2 extra zeros at the end of the number. So 43 multiplied by 100 becomes 4,300. True or false? 2,300 divided by 10 is 230. True. 2,300 has zeros at the end. So if you're dividing by 10, it just means you knock one off, because the decimal would be here. You just move it one place to the left, which means the answer becomes 230. Choose from one of the options available. 546 divided by 100 is... The answer is option 2, 5.46. You put the decimal point in the right place, which means the decimal point would be here, as demonstrated there. You then move it 2 places to the left, 1 and 2. And that therefore makes your number smaller, so your answer becomes 5.46. What is the missing sign in this case? The answer is option 4, it's division. Because if you think, you've got to compare 566,000 with 566. We had 1, 2, 3 zeros go, which means it's been divided by 1,000. What's the missing sign here? Well, a multiplication, of course, because the number has become bigger. The decimal point has moved 3 places to the right, so you're therefore multiplying by 1,000. Missing number here? Well, the numbers got bigger by 3 zeros, therefore the missing number is 1,000. We have multiplied by 1,000. Missing number here? The answer is 100. The decimal point has moved 2 places to the left, which therefore tells us that we have divided by 100. Missing number in this case? The answer is 10. Decimal point has moved 1 place to the left, telling us we have divided by 10. What's the sign and number that are missing here? It's a multiply by 10. The decimal point had moved 1 place to the right, which indicates multiplication, and the fact that it moved 1 place means it was multiplication by 10. So last quickfire round of just practicing your multiplications or divisions by tens and hundreds and thousands. So the first one, 2.34 multiplied by 100. The answer is 234. 15.05 multiplied by 1,000. The answer is 15,050. 23.4 divided by 100. The answer is 0.234. 150.5 multiplied by 10, the answer is 1505. 23.4 divided by 10, the answer is 2.34. 234 multiplied by 1000, the answer is 234,000. 1505 divided by 100, the answer is 15.05. And 1505 divided by 1000, the answer is, of course, 1.505. So to recap, to multiply, decimal point moves to the right. To divide, decimal point moves to the left. How much it moves either to the left or the right depends on the number of zeros in the question. So this is important. Why? Because we need to do a lot of conversions. But just before I do that, if you go on to bbc.co.uk skills-wise numbers, there's a lot of help available there. If this isn't your strength, please make sure you do lots and lots of practice, because you need to be able to master this basic step before we can move on to any more complicated calculations. So why we want you to do this is because you very, very importantly and very correctly need to convert between units. So for example, you will constantly be asked to convert from grams to kilograms, to milligrams, to micrograms, litres to millilitres. These are all the units we work with in pharmacy. Note that mcg are micrograms. So for example, 45 milligrams, how many grams is that? To convert milligrams into grams, you divide by 1,000, because there are 1,000 milligrams in 1 gram. So you need to be able to do this quickly and accurately. You therefore move the decimal point 3 places and your answer is 0.045 grams. How many kilograms is that then? So in that case, you need to divide it further by another 1,000, because there are 1,000 grams in 1 kilogram. So it's 45 divided by 1,000 divided by 1,000 again. How many micrograms? There are 1,000 micrograms in 1 milligram. So therefore you need to multiply. Microgram is a smaller unit, so you need to multiply. 45 times 1,000 gives you 45,000. Let's practice some more conversions from units. So 5,000 grams is how many kilograms? A quarter litre is how many millilitres? 5,500 grams is how many kilograms? 4,750 grams is how many kilograms? And 8.5 litres is how many millilitres? $5,000 grams is 5 kilograms, because you're dividing by 1,000. There are 1,000 grams in 1 kilogram, so you divide by 1,000. Quarter of a litre is 250 millilitres. There's 1,000 millilitres in 1 litre. Therefore, a quarter of it would be 250. 5,500 grams. There are 1,000 grams in a kilogram, so you need to divide 5,500 by 3. So the decimal point goes 1, 2, 3, and you get 5.5 kilograms. 4,750 grams. Again, decimal point goes 3 places to the left. You get 4.75 kilograms. And 8.5 litres into millilitres. You've got to multiply this time, because there are 1,000 millilitres in a litre. So 8.5, 1, 2, 3, and you get 8,500 millilitres. And we won't always have whole numbers, so we need to think about rounding decimals up and down. To round 5.83 to 1 decimal place, it lies between 5.8 and 5.9 on the number line. If you remember number lines, this is our number, 5.83. You got 5.8 there and 5.9 there. 5.85 in the middle. So is 5.83 closer to 5.8 or is it closer to 5.9? Clearly, it's closer to 5.8. Therefore, if you were rounding 5.83 to one decimal place, the answer would be 5.8. Another way of doing that is you look at the number 5.83, you look at the one next to it, that's 3. So if you're rounding a number down or rounding a number to one decimal place, the number next to it is 3. If that's less than 5, that remains 8. And that's why. If it's 5 or more, so if it's here or more, it moves on to 5.9. So you go one decimal place, you look at the number next to it, less than 5, it goes to 5.8. 5 or more, it becomes 5.9. It's closer to 5.8, therefore 5.83 to one decimal place is 5.8. So if we're to round 6.5 to the nearest whole number, so the whole number is just the 6 there. Lies between 6 and 7. 6.5 is right in the middle. Is it closer to 6 or is it closer to 7? Well, it's dead in the middle. So in that case, you always round up. So therefore it becomes 7. How can we round off 6.493 to one decimal place? So 6.493 is 6.5 to one decimal place. Because you look at that, that is more than 5, so that becomes 6.5. We can also round off numbers to 2, 3, 4 decimal places. So rounding to 2 decimal places, place the arrow over the second decimal place. So that's first place, second place. You look at the number to its right. It's less than 5 in this case, so it remains 6.49. You will often be asked to give answers to a certain number of decimal places, so you need to be able to do this correctly. We'll now round off to 3 decimal places. So rounding 8.6935 to 3 decimal places, place the arrow over the third one, first, second, third. That's a 5. Therefore, this will go up. So it becomes 8.694. The next digit, which is a 5 there, helps you to decide. Since the 5 is in the middle, we need a rule. If the next digit is in the middle, 5, then you round up. So if it's 5 or above, you round up. If it's less than 5, you round down. People have got answers wrong in exams because they haven't given the answer as requested. So whether it was asked to a few decimal places or whether it was asked to be a significant figure, it needs to be in that format, or even though your calculation is correct, you get the answer wrong and you don't get the score. So let's have a quick practice here. Just talking about decimal places. Try rounding off these numbers to the given amount of decimal places. 23.488 to 2 decimal places. 1, 2. The one next to it is 8, which means it's more than 5. So that therefore should become 23.49. 209.942 to 1 decimal place. That's the 1 decimal place. The one next to it is 4. The answer becomes 209.9. 2.555, same way becomes 2.56 to 2 decimal places. 3.097 to 1 decimal place. That is more than 5, so that becomes the next number up. So it becomes 3.1. And to 2 decimal places, 78.99, 1, 2. That's a 9, it's more than 5, so that goes up 1. And therefore that goes up 1. So the answer actually becomes 79. If in any of these cases, so say for example over here you put the answer down as 78.9, and the question specifically said give the answer to 2 decimal places, and you put 78.9, you would have got that wrong, despite everything else being right. So you do need to answer the questions carefully and follow full instructions. Pay great attention to what's being asked of you in the question. Okay, now let's talk about significant figures. So here we've got, the Sun wants to do an article on the woman telling the world how much she has won. They don't have enough space in the headline, so they want to use an approximate amount instead. What figure would they use? Her winnings are 7 million to one significant figure. She's actually won 6,725,000. If you're doing it to one significant figure, 6 is the one significant figure there. It's the first one. The number next to it is 7, which is more than 5. Therefore, this gets moved up. So it becomes 7 million. Only way is to practice. So here we go. Round off these numbers to the required accuracy. SF being the significant figure. So, if we look at 34.275, we need to round that off to two significant figures. 3 is the first one, 4 is the second one. So therefore, looking at 2, it's less than 5, the answer would be 34,000. 118,536 to three significant figures, 1, 2, 3. That there is a 5, which means it becomes 119,000. 8,760 to one significant figure, 7 is more than 5, so that becomes 9. 8,697 to three significant figures gives you 8,700. And 35,818.3 to two significant figures. You've got 1, 2 there. 8 is greater than 5, so therefore this becomes 36,000. The 0.3 goes away. It's just two significant figures, therefore it becomes 36,000. We can also round off decimal numbers to so many significant figures. So for example, if you've got 723.65 and you've been asked to round that off to 4 significant figures, you've got 1, 2, 3, the fourth one is after the decimal point, in this case it needs to hang around. The number next to it is 5, which means this becomes the next number up. So you've got 723.7. And that is the answer to 4 significant figures. So quick practice of this, and this is the last practice that we're doing. If you can do these 5 questions to round off the numbers to the required accuracy. So if we just go through the answers here, we've got 6.3169. To two significant figures becomes 6.3 because you had 1, 2, that's less than 5, so it's just 6.3. 219.786 to three significant figures, 1, 2, 3. The 7 is more than 5, this goes up, therefore that's going to go up, so it becomes 220. 9.417 to one significant figure, that's less than 5, so the answer is 9. 85.95 to three significant figures, 5 is greater than, 5 is 5, or if it's 5 or greater, so that goes up 1, that therefore is going to go up 1, so it's 86. And the last one to 4 significant figures, 1, 2, 3, 4, that's greater than 5, so these are all going to go up and it becomes 5.9. So that brings us to the end of the session on decimals. This is the first session. As you can see, we're starting off quite basic, but we are going to move on. By the time you get to the 10th session, you'll be ready to do an exam paper with the calculations that we require you to be able to achieve at the end of year 1. As the years go on, it'll get more and more complicated and more difficult, so we need to make sure the foundation is strong. There is a test that now needs to be done, so please make sure you do that so that you can move on to the next session on numeracy. Thank you.